Hello everyone, welcome to the GeoEcologist. I'm Dr. Krishnanand and you have been watching my videos on various topics of geography, environment, and of late we have been doing this hydrology series. So in this series of hydrology, today we are going to discuss the surface hydrology, where overland flow, the concept of runoff, its various factors, then how to estimate it, all these things are going to be learning today. So if you want to learn this, please watch the video till the end. Everything is going to be discussed for details. And also remember, if you have not watched the earlier videos, you can check our playlist section. And also before going ahead, please remember that you need to share these videos with others more and more possible for more engagement on our channel. And also if you want to support us, please do join our channel and definitely subscribe, like, and do post a comment on these videos so that we have more viewers engagement. So now let's learn. So as you can see that today's topic is surface hydrology, where runoff, overland flow are the main components we are going to discuss, and its factors and estimation is what we are going to cover in this video. Before going ahead, one important thing to be announced here is that if you want to take our paid online classes, online courses, you can visit our website, TheGeoecologist.com. And if you want these content that you see in YouTube videos as for your readings, so you can download the content at geographyebooks.com as PDF, as ebooks. So that's important. Now let's learn and understand this surface hydrology. So first thing that we need to look into surface hydrology is the definition and importance of surface hydrology. So if you see, the word itself is surface. So surface hydrology studies the movement of water across Earth's surface, which includes runoff and overland flow. So if you observe this particular diagram, you see here that if rainfall happens on the surface, it goes down the slope, and here this is called overland flow. And if it also infiltrates a little, it's called through flow through the soil. And if it goes further under, it's called groundwater flow. And finally, it goes into the valley, into the stream, into the river. So now if you observe, what is the important thing here? Today we are going to discuss only the surface aspect, the top aspect. So these processes are very important. They are very crucial for understanding water distribution, which is of great importance in today's world. As you see, drought conditions across the world, heat waves across the world. So water distribution, very important. Managing water resources, very important. And predicting flood events, very important. And not just flood events, but flood and drought go hand in hand. So if you want to understand these floods, droughts, problems of regional hydrology, surface hydrology and subsurface hydrology, both are important. So in today's video, we are here in surface hydrology. In the next video, we'll be talking about the subsurface hydrology. So surface runoff is the first thing that you need to look into. So if you observe that runoff basically is the draining or flowing off precipitation, that is rainfall that happens from a catchment area through surface channels. So if you observe, this is the slope here, right? And on this slope, if you observe, if there is a rainfall happening, the water is flowing here, right? So this basically represents output from catchment in a given unit of time. So here, per unit of time is actually very important, that in how much time, what amount of water is going away, right? How much is it draining, right? So for a given precipitation, right? And now precipitation could be in any form, right? Ultimately, then it melts down to form water, even if it is a glacial form or if it is in the form of blizzard. So when the evapotranspiration, initial loss, infiltration, and detention storage, all these words are very important. Remember these keywords here, right? So when these requirements are satisfied, the excess precipitation moves. So it means what? First of the thing is that all the things on the surface may absorb as well. Some water will go infiltrate as well. So when the excess water is there on the surface, that flows, right? So that is very important here. So portion of runoff is called overland flow and involves building up of storage over surface and draining of the same, right? So if you observe here, a part of the precipitation that infiltrates, which goes inside, here is the word infiltration, if you see, right? So if it infiltrates, moves laterally through the upper crusts of the soil and returns to the surface at the same location or other location. Remember, this is also very important here. A lot of terminologies are given for this. So it's called interflow. Do you see the word interflow? Then you have also some return flow or quick return flow or subsurface flow. So all these flows actually contribute to the final stream flow. Right. So we are talking about overland flow and runoff here primarily. But remember, based on time delay. Now, here is the factor here. Time delay. How much is the time delay between a rainfall or precipitation and the runoff? Runoff is classified into two types. One is called direct runoff and the other is called base flow. So if you observe, this is the base flow here and this is the direct runoff. So first thing is direct runoff. It is part of the runoff which enters the stream immediately after the rainfall. It means what? Delay time will be less. So it includes surface runoff, prompt interflow, rainfall on the surface of the stream. So in the case of snow melt, for example, what happens? The resulting flow entering the stream is also called direct runoff. So other ways, the words such as direct storm runoff are also used to designate the runoff. Now, the next thing is base flow. So what is base flow? It's the delayed flow, means there is time lag here. So time is very important. So time lag is there. So delayed flow reaches the stream essentially as groundwater. This is called base flow. Right. Now, ultimately, both these flows we have learned is part of the runoff that we are talking here. So, coming to the science behind it and understanding behind it, this is not new concept. So, overland flow, if you observe that some of the earliest research has been done by great scholars, and one of them is Robert Horton. So remember Robert Horton, who is this person? American hydrologist, a geomorphologist, also a civil engineer and scientist, and also regarded as father of modern American hydrology, or sometimes called father of hydrology as well. So he is the person behind this understanding in the science. So if you observe during the world wars, when science was growing, technology was growing, this is the time when his classic paper in 1933 comes, and he hypothesized what? That overland flow, which is excess flow, remember the word excess flow was used by Horton. So is basically when rainfall rate was higher than infiltration. So, right? So it's like incoming and outgoing, right? Something like that. So incoming and outgoing balance, right? So if the incoming is now done, so the excess will go into the surface flow. This is basically talking about. So let's understand it more. So when the infiltration capacity of soil, remember if this is the soil and the infiltration capacity of the soil, right, is low, overland flow occurs readily. It means if there is a surface where the soil is not letting the water enter, right, it means surface flow will be more. Now you remember urban condition? In urban area, why do we say this? Because we have done this concretization of our entire structure, and hence you see the surface runoff is very fast, right? It doesn't go inside, so underground water is depleting because of this. So this type of overland flow is referred to as infiltration excess overland flow or Hortonian flow, Hortonian overland flow. And this is defined by Bevan in 2004. And he says that Horton said it was rainfall excess. So excess flow or rainfall excess, you can say, or Hortonian overland flow, whatever you want to say. So this is the basic schematic diagram. Now, example of low infiltration that we were talking can be found within some important soils. For, if you observe here, from vehicle movement in an agricultural field, the infiltration is low, right? On roads and paved areas, on heavily crusted soils, and what are referred to as hydrophobic soils, right? So this is something that we talk about, that if the soil is, thick crusted and it's not broken, remember again, it will lead to more subsurface, less subsurface flow and more of surface flow. So this is something that we need to remember. Now, what are the factors affecting this runoff and overland flow? So remember, the first is obviously climatic factors. And in our playlist on our channel, you have an entire series of climatology. So if you want to learn precipitation, temperature, wind, everything is discussed in detail. Here we have only the pointers. So precipitation is amount and intensity and duration. Three things. How much and what intensity and what is the duration. So it all is affecting the runoff. Heavy rain over a short period of time will have more runoff, and that's why we have which floods? Flash floods. Look into the Sikkim, look into the northeastern region, look into the flash floods in cities that's happening. Temperature, higher temperatures increase evaporation and can reduce the runoff. But remember, snow melt in warmer temperatures can also contribute to runoff. It has two aspects. Then wind is very important as it increases evaporation and transpiration and affecting the amount of water available for runoff. So that's also important. Come to the next important factor, that is catchment area of a stream. So what is the catchment area? So where the river is getting its water from. So this catchment area's topography, soil type, and vegetation is very important. So remember, if topography, that is shape and slope of the land, is very important. So steeper slopes, obviously faster runoff, right? So which slope? This will have faster runoff, this will have less faster runoff. Soil type, as we talked about, sandy soil absorbs more water, reducing runoff, while clay soil frequently runoff. Then vegetation, obviously it holds and it helps into interception, interflow, so infiltration through root and systems. So if you reduce vegetation, you'll not have underground water. So what do we say? That plant more and more trees if you want to have good water table because of these things. Then third important thing is human activities. So in the earlier videos also we have discussed about human activities such as urbanization, and we all know what is happening in the cities. Now these flash floods are happening in cities because of the rainfall. First thing is that it's excess rainfall happening, cloud bursts happening, and the second is city does not have this infiltration process that's happening because of the concretization. So buildings, roads, and other impervious surfaces that we say, the word is impervious surfaces, which doesn't allow the water to percolate or soak. This is happening, so increasing runoff. Then agriculture, obviously agricultural practices are very important, such as tilling and crop type can affect how much water in the soil will absorb. So compacted soil from heavy machinery reduces infiltration. Remember, if the huge tires and machinery is running on your land, it's getting flattened up, no water is going inside. Then you have deforestation, we have talked about it. Then hydrological factors. So when you talk about the structure and hydrology, antecedent moisture condition is very important. The soil moisture is very important. Remember, if soil moisture before the rainfall is very high, obviously it's already saturated, so it will have more rainfall. But if soil is not having enough content, so it will absorb more and more. It all depends. And then drainage network, obviously. So the extent and connectivity of rivers and streams within themselves, within the catchment. So if you have done channeling of the main river and you have disturbed the regime of the main river, the network has been disturbed because of the hydrological structures that we create. For example, dam creation, or we can say canal creation. This will affect the main hydrology, the main catchment area. So we say that it doesn't have only the best effects because remember, we need electricity, we need irrigation water, but at the same time, we also need the health of these rivers to be important. So we need to strike a balance here, very important. And then we talk about the estimation of runoff and overland flow. So here you will see some quantitative techniques and some qualitative methods and some remote sensing method. So first is called empirical method, which is called a rational method, a simple way to estimate peak runoff for small catchments using a formula. And what is the formula? Formula is this: Q is equal to CIA. Remember, it's not the American CIA, but basically Q is peak runoff and C is runoff coefficient, a number representing land use impact, I is rainfall intensity, A is catchment area. So this is how it is done, the rational method. The other is called SCS curve number method. Remember, this was developed by Soil Conservation Service, now NRCS we say. It estimates runoff based on land use, soil type, and moisture conditions. So soil moisture conditions is assessed here. Now, another formula here is this particular formula. You have Q, P, and S values. For that, you need to calculate. Then you have physically based model. So if you observe SWOT, soil and water assessment tool. So it talks about the stimulation and its impact of land management practices. So water, sediment, agricultural, chemical yields in large, complex watersheds we talk about. Then you have HEC, HMS, so hydrological modeling systems. So now we have this flood forecasting and water resource management using these kind of models. And obviously you have statistical methods, which is the old method, regression analysis, using historical data to establish a relationship between a runoff and the influencing factors like precipitation and land use. So you have some direct variables, indirect variables, and we talk about regression analysis. Now you have remote sensing and GIS playing a very important role, especially for inaccessible areas. So satellite imageries are being used, geographical information systems, softwares, and so many analysis is going on. So it helps us to simulate, to visualize how water moves across the land and what is its potential, and also future projections. So remember, guys, these are very, very, very important points. Now, predicting the effects of water constructions. How will you predict? Because on the modelings, so you have various simulation scenarios, scenario modelings done. So for instance, Dams. Remember we talked about it? So water storage, flow regulation, and sediment trapping are three important factors when we talk about dams, because they are affecting these things. So dams create, reservoirs that store water. It controls the release of water, prevents floods, and maintains this. Sediment accumulation is one important point. And also remember canal. We talked about it. So modeling the impact of a dam. So canals divert water for irrigation, urban use. So what's happening to the stream? What's happening to the health of the river? Impact of natural flow we talk about. And obviously precipitation data, watershed characteristics, geological soil information, vegetation cover. All these are very important for predicting the effects of water constructions. And of course, we have simulation models where we use these models, and the outcome of the prediction is when we talk about, so we future project it, and then we can apply that which area needs to be taken care and how we need to take care of it. So now when we have discussed all the aspects of this surface runoff and overland flow, which is part of the surface hydrology in this video, I hope you learned something. These points are very important, and remember to look into the practical applications of these topics around ourselves, because water is going to be very important for coming times, as we see around the world, as we see in India, what's happening with heat waves, what's happening with water supply. So you know that this topic is going to be very important. So learn hydrology, and it should be shared with more and more people, so that they also learn and help in understanding of this phenomena in a locality where you live. That's very important. So this knowledge has to be translated to local people, to commoners, right? Not just to a hydrologist. That's important here, right? So in the coming video, we'll be talking about the subsurface hydrology, the groundwater condition as well. So stay tuned, keep subscribed, keep learning and sharing the videos. Best wishes. Take care.